Okay, hello everyone. It's 9 o'clock, and thanks for coming. This course should be delivered in English because this EMI courses. All right, one of the EMI courses in MSE, and welcome. Okay, welcome to Thermodynamics in Solids. However, um, well, from like 20 years ago, okay, this course name has been set for like this thermodynamics in solids. However, the textbook and the content of this course is not thermodynamics in solid. It's actually called classical and statistical thermodynamics. Okay, so the purpose of this course is actually connecting the existing basic thermodynamics theory and knowledges. Some of you may graduate from material science engineering department, but the other students may not. Okay, they may graduate from mechanics or civil engineering. They're all possible. Okay, so some of you may not learn classical thermodynamics before. So this course is actually give you a review, like 3 or 4 weeks review for classical thermodynamics, and then into statistical thermodynamics, 统计热力学，传统跟统计热力学。All right, so basically this is the content of this course, and if you find that this is not what you want, you can say bye-bye. Okay, because suppose we will. Do you know how many people is here? How many students taken this course? 100, right? 100. So it's plenty of students. So which means that if you really think maybe this is not what you want, or you think my teaching style is not what you want, feel free to quit. It's okay, right? Okay. Although this course in EMI record in this NYCU was the highest satisfaction rate in this course in this university， 就是那个叫什么课堂满意度是EMI 全校最高过，哇，很感动啊！那我们就来看看到底为什么会这么受欢迎，我也不知道为什么。OK，right， so 还蛮那个自豪的。All right, so my name is Nien-Ti Tsou. OK， 周年地。那I'm an associate chair in this department, 副主任 and my office is 35 at my office. My office 353B. Okay, and my email is TSOUMIENTI 周年地 right at nycu.edu.tw. All right, so this is my email. Please email me before you come to see me, before you knock my door. Okay, please. That's it. And our teaching assistant, Lai Lijun. Okay, she's my PhD student. She's really good. And the second time, right? This is your second time to be a teaching assistant, so she must be really experienced. All right, so she can help you everything. But okay, this is her email. But again, before you want to ask her, okay, please join the Facebook club. Okay, I will. Right. Well, don't worry. I will upload my entire course recording, including this handwriting. All right. So don't worry about this. If you miss anything, if you cannot follow, you can go back home and watch my video, download the handwriting version. All right. But I encourage you to download the blank version of handout and note with me, annotating the notebook with me. All right. It will, help you to learn, help you to remember. But if you cannot attend the course, it's completely fine. Okay, because I have plenty of resources that allow you to learn in your house, in your dorm, in your yeah. So before that, please search in your Facebook club NYCU MSE 2025 for Thermodynamics of Solid. All right. Remember, you search it and choose the category club. Okay. Otherwise, you may search to other, I don't know, movie or post from other. 你知道我在讲什么哈？就是你在 Facebook 上你就搜寻这个，请你搜寻社团，不要搜寻到其他的贴文，这样就很难找得到。So please join this. So far we only have 2 members here, me and TA Li Jun. And in this Facebook, I will give you a lot of information like class video. This is my YouTube channel. All right. And the YouTube channel, I will create a list for this course. Okay. So it will just like this mechanics of material 2025 EMI, blah, blah, blah. And I will create exactly the same thing for this course. If you are not satisfied with my lecture this year, you will feel free to watch 2024 EMI course of this course. Well, supposed to be the same. Okay. Yeah. So actually, all the video are available here for you to watch it. And also, streaming link. Actually, I also provide the live streaming. Actually, I'm recording it, and you can, join this anywhere, join this course anywhere, anytime you want. So you have the maximum freedom for learning this course, and course handout can be downloaded here. And here is, you see, they are all, sorry. See, blank, okay, some space, and I will fill it during my lecture. I encourage you to download that, print it out, or using your iPad or something, and you can note with me. This is the style of my course. All right. Oh, by the way, today, because I received many emails from students. Okay, because there are some sort of laboratory safety instruction something. So most of the students need to attend that, but it's okay. As I mentioned, you can see my video on the YouTube, so you don't worry about not attending the course or miss any course. Don't worry. All right. So please download it and note with me. You will obtain the best learning, effectively. Okay. Right. Another thing is that, as I mentioned, before you ask your question to Li Jun, I create a thermal TA by using ChatGPT. Okay, I upload all my handouts, data, textbook in this. Okay, so this is tailored. Okay, tailored. This is tailored ChatGPT bot rather than the random ChatGPT for all. OK， 听懂我在讲什么吗？我把课堂的所有的资料都上传上去了，所以它是有读过我们的这门课的资料，所以它是特制化的，不是一般的 ChatGPT for all， 所以它应该可以听得懂你在讲什么，问你，甚至可能会告诉你 page。OK， and to make this better and better, I will give you everyone, okay, this link so you can ask. And also, please, if you use that, please see that means. Sorry. Let me see. Wait a minute. Here. Okay. So I will also give you the answering survey. All right. So it's your number, your name. So what did you ask? And copy paste the answer and rate your certification and give the comment. So how can you make it better? All right. So along this semester, this robot will be better and better and better because of your input. All right. So let's do it and make a really good thermodynamics teaching assistant robot. So and I believe you can, ask the problems or example in the textbook, and then supposedly it will give you the answer. Suppose, okay, but make sure that you will check if this is correct or not. Don't just, trust it without thinking. This is not good, okay, because ChatGPT always give you illusion sometimes. All right. So please just make it as an assistant for your learning. And then if you really cannot understand what is said, you can seeking teaching assistant for help. All right. And if teaching assistant cannot help you, you may refer to me. All right. So any questions so far? All right. So yeah, that's it. 应该没问题了，谢谢。Okay. Let's continue. Okay, so the grading, 10% class performance. Well, because we don't, sometimes we don't, we don't do the 点名要讲啊。I don't record your attendance, but from time to time, because this is a 9 a.m. course, right? So sometimes I will do bonus for students who are on time, okay, within 1 minute limit windows, okay, 9 a.m. to 9:01 a.m. That window you already arrived, which means that you are really on time. So I will give you the bonus. All right. Sometimes, randomly possibility. So this is just a encouragement that you be on time. Okay. Responsible student, you and me. All right. Good. Okay. So, and also the 10% class performance will be related to the survey. Okay. How you use Facebook Club, how you use the teaching assistant, the Thermo TA, ChatGPT, and how you respond the questionnaire to make it better. If you put your effort in that to make it better, you will have a higher class performance. Okay, because I will note your, numbers, right? So I know who is putting your effort on that. So this is one of the class performance from you. and 30% midterm 1, 30% midterm 2, 30% final exam. All right, next. So this is a course syllabus. So you can see that midterm 1 is based on the review of classical thermodynamics. So most of you may learn that before. And yeah, so you just make a review and you will encounter the midterm 1. And then we get into the statistical thermodynamics, and then introducing some distributions and ideal gas, diatomic gas, and then heat capacity of solid. Basically, this is the whole terms. The reference book is Classical and Statistical Thermodynamics, Ashley H. Carter. All right, so you can just buy it. I would recommend you to buy it because the problems and example are all in this course from this classical and statistical thermodynamics textbook. All right, so I encourage you to buy it. Yeah. So if you need the I don't know actually. Well, you will find where you buy or where to buy it, but please don't use pirate version, okay, or download the pirate version from internet. So this violates the copyright rules, all right, copyright law. So please don't do that. And the rest of that some references not that as important as this one. All right, so okay. And what? Anything else? No. All right. So the introduction is done for this course, how it works, how it goes in the semesters. Any questions? No? All right. So let's start. And today I will only give you 2-hour lecture. All right. So I will finish before 11. All right. Finish before 11. As we said, there are plenty of students are not here, and some of them may not sign in this course. They may need my handwriting sign in. So I shouldn't push the progress too hard. So only 2 hours today, okay? Originally, in the previous few years, I only give you 1 hour for the first class, but it cannot be the case this year because this semester become 16 weeks, right? Previously we have 18 weeks, so which means that we need to be hurry. Okay, we need to hurry to otherwise I cannot finish this course in time. All right, finish the content or cover all the contents in time in one semester. So I need to give more lectures or more efficient or quicker, faster pace. Okay. So what is thermodynamics? I believe you know that the Albert Einstein thinks that this is a really good knowledge, good theory. Is that, as he said, a theory is more impressive. He is impressed. Okay, he thinks it's good. The greater simplicity, very simple. Well, in his mind, he thinks it is simple, but to us, it's a little bit difficult. But he said this is simple and elegant. Okay, because it is related to it can apply to a lot of area. Okay, everything in the world or follow the law of thermodynamics. Okay, and it's the only physical theory of universe content. Wow, everything. He said, which I'm convinced. He is convinced by thermodynamics. Wow, convinced that such genius, the most talented human being in the world, is convinced, which means that this must be correct. Okay, with the applicability of its basic concept, it will never be overthrown. Well, he also said it will never be failed. It must be correct. Wow, this is really big compliment for this knowledge, for this theory. Okay, so everyone should learn thermodynamics, right? 听得懂吗？我以后每一页我都会讲完英文以后，就会用很快速度讲中文。哦，总之就是爱因斯坦他觉得这个很棒，他觉得印象很好，他被说服了，因为它很简单，然后又不会被推翻。他觉得这门科学绝对不会被推翻。Okay, so what is thermodynamics? So now you see my style, writing style. Okay, what is thermodynamics? Thermodynamics is the study of equilibrium property. Equilibrium property. Equilibrium means stable, which means that I will give you more detail about the equilibrium. All right, and the property which related to temperature. Temperature, 温度, all right, which is important variables. Yes. Temperature is always related to the energy, right? So actually, this course is related to the energy, how to make it minimum, how to, the state is stable state. Okay, and it is okay, this word is long. Phenomenological. What does that mean? Phenomenological. Phenomena is something happened in the real world, and this theory is actually based on something actually happened in the world. So never been overthrown because it happens. Always be the truth. Okay? 现象学. Okay, based on the truth. So theory. This theory is always based on the thing actually happened. So it always be right, always be correct. Okay? Great simplicity and generality. Very simple. Well, it said you can use simple equation, but it's difficult to understand. All right? Okay. Simple equation to describe the things and not trying to explain underlying cause. This is really interesting. So it just tell you what will happen, but never tell you why, and also never tell you how fast or how slow of this procedure. Okay, so it's just tell you, yeah, it will end up like that. Okay, yeah. The statistical approach is taking molecular constitution of matter. Okay, classical thermodynamics, and what you learned before, some of you learned that before, is based on the material is entire things. It's a whole. I mean, treat that as a whole stuff, whole thing. Okay, but actually, everyone knows that everything is consist or built by molecules, many small balls, small atoms. Okay, so the statistical approach is actually treat the thing as many molecular, okay, many atoms, and reveal deeper foundation. Yeah, you understand that, right? Because they are all small atoms. We talk about small atoms. And when we talk about small atoms, all the activities of the atoms, we sum it up together and average them. And surprisingly, it will equal to the classical thermodynamics concept. So small parts, all the small part activity, and you do the average, we do the ensemble average or some approach, and then we found that the properties actually is equal to the whole properties. So very, neat, very elegant, very smart. Okay, and if you have two approach, classical and statistical approach, and obtain the same answer, which means that this answer must be correct because you examine this answer by two different approaches. Nice. So you see, macroscopic measurement, classical thermodynamics, okay, because you see everything in a large scale. Macroscopic measurement are average of the behavior of small particle. That's what I'm saying, okay? And it tells you what will happen, but you never know how long it will happen, okay? So that's why Albert Einstein thinks this is great simplicity, okay? Because it just tells you what will happen, but the underlying cause, reason, and how fast of it, how slow it, I said, we never talk about this. All right. 好，这是一个非常快速的讲解，就是说，热力学其实是跟温度有关的现象学，因为它基于真实的事件，所以它绝对不会错。OK， 然后它很简单，为什么呢？因为它只是告诉你它它会到达什么样的状态，但是它不会告诉你多快多慢，也不会告诉你为什么。OK， 那传统热力学是把一个物件当做是全部整体，我们叫它巨观的性质，可以量测得出来的。但是统计热力学不一样，它是把里面每一个 atom 每一个原子每一个分子都去考虑进去，看它的每一个的行为，然后把它统计起来，不管是积分还是叫什么平均等等的也好，做很多种统计法，结果发现算出来的性质跟巨观的一样，那就表示说两个都对，好，验算对哈。All right, so again, more detail about macroscopic and microscopic. Macroscopic is for classical thermodynamics. The scale is in the classical thermodynamics scale is in macroscopic, treat the system as a whole, and require direct experimental data. When you measure do the experiment, you measure data and you use that. Okay, microscopic instead is microscopic scale is for statistical thermodynamics. You treat the system as a collection of discrete entities. So atom, basically. Okay, atom or molecular. Okay, and right. The limitation for classical is that you use experimental data. You need to do the measurement. But the microscopic in statistical thermodynamics, you depend on model. What is model? Model is actually created by human scientists. So if you are a different person, if you are different scientist, you may come up different model. Okay, so you're using your model to interpret it, to explain this system. So maybe you have your own assumption. Okay, maybe this researcher has their own assumption. The other one has their own assumption. Their assumption will make leading some error, but sometimes the error is acceptable. Okay, so the model should be still useful. All right, so you can imagine that different model of the statistical model, 统计模型, okay, different statistical model may lead different answer, but sometimes they will have the same trend. Okay, sometimes they may have their own disadvantage. Okay, so for example, if you have a system looks like this, and you may treat that a lot of atoms, but someone in the other model, they may treat, okay, these three are in different three groups. So different way to treat that model leading to different results. Okay, but they may end up a similar trend of this system. So model is kind of important. Right. 巨观跟微观，好，这边先写的。巨观当然就是传统热力学，微观就是统计热力学。巨观就是把它看一件事情看的是全部，然后它所有的就是计算或是知识都是靠实验量测出来的现象学嘛，哈，实验量测出来的值，实验量出来它会怎么样做，怎么样变化。但是统计热力学有点不一样，统计热力学它就把它就想象啊，它是想象它是由什么样的 atom 什么样的分子去合在一起的，然后它就很吃人的想法了。好，例如说这个科学家觉得说，哎，他这个现象应该是依据这样子的行为，然后得出来的结果。那另外科学家觉得是另外一种啊，好，那他们用不同的思考去创建一个模型，模型其实就是一个像一个你自己想的玩具，你自己想的一个系统。那所以他们当然自己有自己的假设，那这些假设都可能会导致一些错误，导致一些误差，但只要这个误差可以被接受，那也是很棒的一件事情。那这个模型还算是有用，还是可以提供你提供你趋势 ，OK？所以这还蛮吃就是模型的，不同种类模型就会有不同的计算方法，但可能会得到相同的结果，或者得到相同趋势的结果。那我们之后会再看。Alright, so now I'm going to introduce some terminology of this course. Alright, the first terminology is system. The system is a part of world which is isolated from the rest of the world. Alright, the system by defined boundaries. Basically, this system is the material we are talking about. Material. Okay, this is material, and it has their boundary. Okay, this material or this system is isolated, different from the rest of the world. Okay, you examine this stuff. All right, material. Okay. For example, a container of a gas. The gas inside this container, and a piece of metal, a material. All right. Surrounding. So outside of a given system. Okay. And universe, the system along with its surroundings. So everything is universe. All right. All right. 好，名词解释，系统听起来啊，好像很恐怖，什么东西啊？没有，它就是你要看的那个 material 那个材料啦，哈。例如说，一个容器里面的气体，或者是一片铁、一片材料啊，就是你那个东西就是你的系统。那旁边的东西就是它的 surrounding 叫做周遭的环境吧。然后两个加在一起的集合就是 universe，宇宙也不对，反正就是全部的东西。universe 中就是全部的东西啊。OK，next 啊，休息一下，还可以吗？听得懂吗？现在应该可以吧？哦，我讲的话大家应该听得懂吧？英文 OK 吗？英文 OK 吗？哎，对了，你觉得英文需要翻译吗？大家觉得英文需要翻译吗？我自己是觉得说，大家的英文程度都越来越好了。我以前刚进这个学校的时候，13年前，好吗？啊13年前12年前好了12年前，那时候我的英文比学生都好，然后我觉得好险，因为我那时候才刚从英国回来嘛，所以那时候英文还不错，但就越来越差，越来越差，越来越差。然后我发现学生英文越来越好，越来越好，越来越好。为什么？我看到他们的那个多益的成绩，那个申请入学的多益成绩，每一个都金色啦，每个都是800、900啦，超猛。然后啊，我们在面试的时候，有的时候会有人跟我说，就是他的英文很好，然后英文很好，让我看，哎，是很好，没错啦， 就是比我那时候，我跟他一样年纪的时候，他一定比我厉害，但是他也没有金色证书，然后他觉得他很有自信，但实际上他很厉害了，可是其他人全部都是就是900多分，所以我就觉得哇，这个太夸张了，现在这个英文实力的通膨会不会也太夸张了？好，所以我想说，搞不好大家英文现在应该都比我好了，哎，那所以搞不好我不用翻译，需不需要翻译啊？我们去年啊，哈，有做一个投票，就是这门课要不要做翻译？那去年还是要我翻译啦。那今年我们来投票一下，好不好？我们大家加入了社团以后，我们来投票。不用翻译的话，会加快很多哦，速度会变很多，很快。然后上完课，大家就可以不用，大家就可以不用，就不用上课了，哎，好不好？我们来投票一下，好，到时候 Facebook，然后2、3个礼拜以后的投票，OK？好，对啊，因为我英文讲的也算慢吧，或者是正常吧，哦，算是清楚的啊，我觉得我有点自信，所以说如果你听不懂啊，要我翻译啊，你就投票，我说要。那如果你觉得你就可以完全可以接受的话，哎，那我们就搞不好今年将会是第一次我不用就是翻译的，OK。So I will host a vote, okay, to see if you need my Chinese translation every page. All right. So I hope you will be the first semester that I don't need to do the English translation to Chinese. Okay, good. Right. Let's continue. The type of systems. The system may have three typical case: open, closed, isolated. As you can see that the system one has no cap. Okay, so the water will evaporate. Okay, so it's open, so it can exchange mass. Okay, and also it can exchange energy. All right, so the heat may released. All right, and the closed is that there's a cap on it and no exchange of mass, so the water may not evaporate, stay the same, but the heat still can be exchanged to the surrounding. But isolated means that it cannot exchange mass with the cap, as well as the wall, the isolated wall, make it no heat transfer across the boundary. All right, so no for exchanging mass and energy. All right， 快速的就是有3种不同的系统，第一个是开放、关闭跟隔绝 ，OK， 然后第一个是质量可以离开，热也可以离开。第二种就是质量不能离开，但是热可以离开。第三种就是全部都不能离开，是这样。Next one, properties. Oh, properties is so important. All right, property is so important. Property is to describe the macroscopic behavior. Macroscopic behavior. So, which means that when you do the experiment, you measure some materials has some value. The value is actually macroscopic properties. Okay, which means that it describes the entire material that you see, and the value you measured is in large scale. Okay, you can see that, you can hold it, you can calculate it. Typically, all the classical thermodynamics theory related to the macroscopic properties. There are 2 types of properties: extensive, intensive. Okay, extensive is proportional to the mass. Okay, So if your mass increase, extensive property will increase simultaneously. Okay. For example, volume. Okay, volume. If you increase the mass, suppose you increase the volume, right? If you increase the mass, your work also increase because it can deliver more force, so you can increase the work. However, intensive properties is independent of the mass. For example, your temperature won't change if you increase the mass. Your pressure won't change, or density won't change, right? Density. Okay, so the density, you know that, right? If you change, if you even increase the mass, your volume also increase, right? So your density, the ratio of the mass and the volume, will still the same. Okay, so you find that basically you can make the extensive property into the intensive property, okay, by dividing the mass of the system. So it will take out the influence of the mass. All right. So it called specific value. 比呀，比的值啊。So value of the extensive property divided by mass of the system, and then you take out the dependence of the mass, and then you can obtain intensive properties. For example, the specific volume. Okay. For example, small v equal to big V divided by N. All right, so you see that there are two important things here. You need to pay attention. This V is volume. This V also volume, but this V is, macroscopic volume. But the V here, small v, means the specific volume. All right, so which means that it is not dependent to the mass increment, because you divide the mass of the material. So it is mass in kilomoles. All right, I will highlight here kilomoles. The N here is mass in kilomole. The kilomole is the unit we use in this semester. We use in the textbook, exam, anything. All right. So please be careful. Our unit is kilomole. Kilo. All right. 1,000 mole. All right. So the N here will always kilomole. Right? What's wrong? All right. So when you divide, you use the extensive property and divide by the N here, mass in kilomoles, and you will obtain the specific properties. And it is in intensive properties, and you write down in small letter. Okay, small letter. Very important. Next, the properties are all related to the state. The state, okay? A system is defined as a condition uniquely specify a set of properties. Oh, okay. Now, there's material, and you want to say what kind of state it is. What kind of state this material is at, okay? So you need to use the property. You need to use properties to describe this state. For example, this material is under 1 atm, 30 degrees C. Okay, so this is, you use a lot of property like temperature, like pressure, even weight, mass, to describing this material at what kind of status. Okay, so different state, which means, okay, if you heat it up and then it becomes 100 degrees C, it from this state to other state. Okay, the properties were describing the state. Okay, for example, very senior high school level things, PV equals MRT. Okay, so you can describe the state of a gas in the container by using PV equals MRT. What is the pressure? What is the volume? What is the mass of that gas? What is the temperature at that moment? All these values explain or describing the status of that gas in the container. All right, so that's the state. 好，我们要讲的这边有性质跟状态 state。那性质就是你看到这个东西的巨观的状态，好的性质，这要怎么解释啊？这好难啊。也就是说，例如说这个东西的的重量啊，这个东西的体积啊，这个东西的密度啊、温度啊、压力啊的状况 ，OK， 你都可以去量测出来。然后，如果今天这个性质是跟质量成正比 ，proportion 就是正比的意思。正比的话，增加质量就增加那个东西啊，那个性质叫做 extensive property。如果跟那个质量没有关系的话，它是 intensive property。那其实我们可以把 extensive property 除上 mass 的值，你就可以得到比体积啊，这个比呢，注意哦，小写，没有除过的是大写。然后除这个 n 啊，这个 n 在我们课堂上是用 kilomole 啊，千摩尔哦，不要忘记了，不然都会差3000，差1000。然后呢，这个状态其实就是一个定义一个，这个状态是靠性质来去描述的 ，OK？ 那就例如说像 PV 等于 MRT， 高中都有教过，一个气体在 container 里面，容器里面，它的压力多少，体积多少，温度多少，质量多少，就可以去形容它的状态。OK？So I guess I need to give you 20 minutes for break, and I will see you after that. Thank you. If you have any questions, just come here.
假如就会放在
会，
然后所以是要等加入之后再讲。
对，其实对你现在可以加入吗？
因为它是私人，你要等整个通过。
好，
那我想问一下，是这个范围是不是跟物化的这一段比较近？就是物化的物理化学的这一段。
比如说我们现在讲的这个东西哦，差不多，对，这都是一些基础名词介绍。
然后是要等到后面那一段，对，要像统计热力学那段。
对，在 midterm 1以后就会变成统计热力学。所以实际上你物化哦，可能也不止物化哦。我跟你说，你是化工系吗？还是 硬化系还是什么之类的。
我之前生技系就有上过物化一个。
Right，搞不好你们的热的符号会跟我们的不一样，Q 的符号会不一样。
不一样。
哎，对，就可能要注意这件事情。哎，其他的都差不多。哎，谢谢。
第一次你讲
你是说跟期中的期中考周吗？对，我考上，所以不会是期中考周。对，其实我也不敢完全的保证，因为每次上课的那个进度会不太一样，但是我会在大概2周前就会跟你们讲。对对，OK，谢谢。加入 Facebook 你就可以看得到了。它不在 YouTube 的连接里面，它是变成一个，你看像这样子。等我一下哦，等我一下哦，在哪？在哪？在哪？在这里，在这里。就如果你加入的话，现在好多人加27了。这边这是 video，然后这就是 streaming 嘛，然后这个就是那叫什么课堂的讲义。然后我今天写完这个，我会马上上载上去。没关系。也没关系，因为的确是我才刚讲而已，我也还没有上传，所以说我会在 Facebook 上就是公告连结给你们。Facebook 叫做你看上面 MSE Thermodynamics of Solids，你就搜寻这名字，在社团上，社团的类别啦，搜寻要点社团类别，不然的话你就收到其他的影片啊，或者是贴文等等的东西。
所有东西都会在这里。
所
有东西都会在这里面公布。
对，没错，对。